But although global warming will be weaker and delayed here, it's going to happen. And we're going to particularly see that later in the century. If you look at the Cascade snowpack, I was involved in a controversy about this. If you look at the Cascade snowpack over time, it's 2006, 1976, last 30 years ago, there's been up and downs, but there's been very little trend at all. If you look at the change in the winter air temperatures over the planet from 1979 to 2008, you'll see, yes, the Arctic is warming up, the continents are warming up, but the Eastern Pacific is actually cooling. Cooling. Not warming. So one question is, can we predict climate change when we can't predict next week's weather? And the answer is, yes, we can. I'm a weather forecaster. Weather prediction, we forecast the exact state of the atmosphere at some time in the future. Like tomorrow's high in Spokane will be 67. It will rain tomorrow at 3 p.m. or exactly where that low pressure center is going to be. In climate prediction, we do not do this. We predict the average quantities over an extended period of time. Like the mean winter temperatures will be 3 degrees Fahrenheit higher over the Northwest. And it is much easier to predict the average quantities over extended periods of time than what's going to happen at that particular point. But even more important, the average conditions over a period of time are highly controlled by the net radiation reaching the planet, leaving the planet. And that is something that, if we know what the greenhouse gases are like, we can get a pretty good handle on. So the answer is we can do this kind of climate simulation. Should we expect stronger storms and more floods due to global warming? The answer is we don't know. Not here. There is no certainty that stronger storms will strike here in the global warming. The number of windstorms and floods have increased during the last decade or so over Washington, but it's not well known that it's actually decreased in southern Oregon and northern California. Decreased. Now, storms tend to follow the jet stream. It's a current of strong winds in the upper atmosphere, and most climate models predict that the jet stream will weaken and move northward under global warming. Thus, it is possible that we will actually see weaker storms and less storms here under global warming. It's possible. We're just not sure. Finally, does the lack of warming during the past 10 years mean anything? George Will and a bunch are saying, well, it hasn't warmed the last 10 years, we should give up this global warming business. And what I'm going to tell you is the answer is no. It really doesn't mean much at all. The trends of atmospheric temperature are really a superposition of several things. First, you have the greenhouse effect. The greenhouse gas increased in mankind. That's causing a warming that's progressing in time and increasing exponentially. But there's also natural variations in the atmosphere. 2 minutes. And so the sum of what happens is the sum of the warming and the natural variations. And so you can expect, especially when global warming is, the greenhouse gas effect is relatively weak, there'll be periods where the natural variation will be causing cooling superimposed on the warming due to the greenhouse gases that you can have level periods, particularly now before the greenhouse gas effect has become dominant. Eventually, the man-induced global warming is going to win. But at this point in time, you can have periods where things level off. And so if you look at the change in temperature over time, you may look at the, okay, it's going up, but there are periods where it's level. And that is probably associated with things like natural variability. And just, we have an economist here. The stock market, that's true too, right? There are these periods of level. There's natural variability in economics. Let me end. I have 1 minute, and this takes too long. But we've done regional simulations here of the Pacific Northwest. At high resolution, we're using weather forecasting models forced by these global models, and this is what we show is going to happen. Here's the difference in temperatures, air temperatures from 1990 to 2020s. There's the temps in Fahrenheit there. You know, warming up by a degree or 2 Fahrenheit, nothing too bad. 2050s, it's starting to warm up more, but some places it's not so bad. But in the mountains where the snow is melting, it's warming quite a bit. But then if you go to the late part of the century, it's a different story. There's an exponential, and it's going to warm up a lot by the end of the century. And it shows you the number of days with temperatures above 90 degrees at SeaTac, Okay, it's not going to be that different in the 2020s, but in 2090s, it'll be warm. Snowpack decreasing substantially, and I'll skip that, and don't buy any ski passes after 2000. Okay, I think I'll end there, I'm out of time. Quick question. Yes, sir.
I just want to know, I guess, what the variation in the temperature will be, or if the climate model can actually predict it. So like they have like average temperature, but I've also heard that we'll have like more really like hot years and dry years and flooding years. But from this, I haven't seen any of that.
You're asking about how will variability change?
Right.
And I'll tell you, the answer to that is going to vary where you are. And so I really can't answer that. For instance, if the jet stream goes north of us, we could actually see, within winters, less variability. So I think the bottom line is, I can't answer that question very well. Yeah.
Why is the Eastern Pacific the last to warm? Is that an easy, quick answer?
But it has to do with the ocean circulations. Well, the water warms up more slowly than land, and it has to do with the circulations of the ocean. But I don't have time to go into it in detail.
All right, thank you. So we'll have more time at the end of this panel, so we'll bring folks down and we can ask